x to the fourth or 4 to the x? Well, ask which one is changing. When we go to get that, which one are we going to want to change, the base or the exponent? The base. If the base is going to have to change, then surely that's got to be where the x is, right? Okay, so it must be the base is changing, so it should be y equals x to the fourth, because I want to manipulate that base of 4 to 4.1, so that needs to be where your variable is. That's what's going to vary. Right? So with that said, what is f prime? 4x cubed at what x? 4. And what is dx? You're a step ahead of me. What is the dx? That's the 0.1. We're going to change from what it was 4 to 4.1, so x is changing by 0.8. All right then. If I were to crank this out, I get 256 plus, I imagine 25.6, if I'm not mistaken. Wait. So it is 256 plus 25.6. Oh, you don't have a calculator for that. 280, 1.6. Sweet. Okay. Another differential idea from Friday is the idea of relative and percent error. Number 21. The side of a cube is measured as 10 centimeters, okay? How accurate must that measure of the side be in order to get the percent error estimate of the volume below 5%? All right. So the idea is if you have a cube, we want our relative or percent error in the volume to be less than 5% off. In order to get the volume measurement that precise, we need to measure the side pretty precisely. How precisely? That's the question. Okay, so can you tell me what the heck to do? We want the error in the side measure. And so what are we really looking for? The error in the side measure is how much the side measure could be off by or changed by. So we want how much error could the side be off by in order to get the volume error down below 5%? I don't usually start, this kind of is working backwards. Normally we have how closely we measure the side and we find how much volume error, but we're working backwards. So let's go backwards. How do you find percent error? How do you find relative error? Relative error is the idea of relating the error of the measure to that which you measured. Now we're talking volume here, yeah? So the error is dV, and that which you measured is V. That's the idea of relating your error in your volume measurement to the volume itself. As a percent of the volume, how much error did I have? Now, this is relative error. Percent error then would be to take that decimal and make it a percent by multiplying it by 100%. So that's the place we want to start from, is the volume error needs to be less than 5%. Okay? Now I want to go backwards from this and make some kind of dx kind of conclusion. So let's maybe start with a little bit of cleanup. dV to V, the relative error must be less than 1/20th. Okay? What about dV? Okay, wonderful. V prime, V, D isn't V, dV. I heard you say 3x squared. I think you're one step ahead of where I want to be. So dv is v prime dx, right? It's the derivative, the rate of change times the amount of change in x. Right? Okay. What is v prime now? V prime is 3x squared dx, and the volume x cubed less than 120. We could put numbers in, then cancel, or we could just cancel first. Do you agree we're going to dump two x's? All right, so we'll have 3 dx's over an x is less than a 20th. Okay, now what? What do we want? Okay, you could plug in 10. You know that the side measure is 10, so we could plug that in. That's cool. If we isolate dx, there's no reason I can't take 3/10 out and multiply it over, so get something like 1/20th times 10/3, or dx must be less than, or the error in the side measure must be less than 1/6 of a centimeter. You can be no further off in the side measure than 1/6 of a centimeter in order to get the volume within 5% of its truth. You with me? That takes practice. In fact, I'm debating whether to do a full extra practice sheet. But here you go, the lesson. Do you know all 6 trig antiderivatives? No. Okay. Do you know 2 trig antiderivatives? Yes. Your antiderivative of sine is? Who leads with 1 over anything on that answer? Let's try again. The antiderivative of sine is negative cosine. There's definitely not any 1 over anything in that. And the antiderivative of cosine is sine. All right. You, by the end of this lesson, should know the other 4 antiderivatives. Antiderivative of tangent, cotangent, secant, and cosecant. All right. The first 2 are very straightforward. You should be able to come up with them on your own. So do that, and then we'll go over them together. Good. How's it going? All righty. Did you show effectively why they are what they are? Okay, cool. All right. Now, next order of business, before we get to secant and cosecant, which are the hardest parts, we'll save those last. Let's go to slightly harder, where you have tangent and cotangent, but powers of those. Some are easy, some require you to get a little creative. How would you anti-differentiate tangent squared? Excuse me. Tangent squared. Anybody have any ideas? This one doesn't take a genius. Come on. You could go sine squared over cosine squared. I definitely probably tried that first myself. I can tell you that goes nowhere. Try something else. Use an identity. I heard secant squared minus 1, yeah? Does that do anything for you? That's good. What's the first antiderivative? Secant squared is the derivative of tangent, and negative 1 is plus c. So, use an identity. Right? Cotangent cubed. Do you have any ideas there? Split off one cotangent, is that what you said? I like it. A lot of identities for squared terms, but none for cubed. So let's split it up. Okay? Any ideas on what to do next? Use an identity, yes. The cotangent squared is equivalent to cosecant squared minus 1. If I let's distribute. Cotangent cosecant squared minus cotangent. Okay? What is the antiderivative of, how would you go about cotangent cosecant squared? What? Yeah. Could you use sub that? The answer is yes. You can actually use sub that two ways, different ways, both one word. What's one of u? U is, let's say that u equal cotangent. What's du? What's the derivative of a cotangent? Negative cosecant squared. So that would be something like, oh man, I'm running out of room. U negative du, which is negative 1/2 u squared. So that first one is negative 1/2 cotangent squared. And what about the antiderivative of negative cotangent of x? It's just we already know the antiderivative of cotangent. Straight at the top of the paper. Antiderivative of cotangent is natural log of sine. Yay? All right. Could you also imagine a multiple choice of plus log of cosecant? If they use log rules, couldn't you also write that plus log of cosecant? Okay. So always be aware of that possibility for multiple choices, but you'll work out that when you come to it, or if you don't see your answer, I guess you'll have to work it out. All right, last but not least, for this section, tangent to the fourth of 3x. I'll let you give that a go with your math amigos. Start a little coffee, and then we'll vote. Okay, are we done? What you sissies, come on. Come on. It doesn't help you to call you sissies? How about wimps?
You got this. I'm working.
You can do it. Keep trying. It's okay that you're taking forever.
Yep.
The learning process is a slow, arduous. I'm going to separate this. How are we doing? Okay. Where did you go with that first one, or can you see the first one? Yeah, U sub, this would go pretty well. Do you agree that if U is tangent of 3x, then this would be U squared? The gotcha to that, though, is the derivative there would be secant squared of 3x times the 3. Do you agree? So how will you deal with that 3? U is secant, du is secant squared 3x times 3 dx. So wouldn't that mean du over 3 is secant squared of 3x dx, right? So that first one is more like u squared times 1/3 du. So all said, then, what kind of constant do you have in front of your first term? 1/9. Yeah, 1/9 of u cubed. So 1/9 of tangent. Wait. All right. Tangent squared 3x. That should look familiar. We just did tangent squared at the top of the page, or actually right above this, didn't we? We do tangent squared by calling it secant squared minus 1 identity. So I'm feeling 1/9 tangent cubed of 3x. Wait. What's the antiderivative of secant squared of 3x? Yeah, it's tangent, and you need a 3, yeah, or a third. Is it 3 or a third that we took? A third of tangent of 3x. Check it and make sure, would that work? Well, the derivative of tangent is secant squared 3x times 3, so that third would knock that out, so that looks good. Minus, or is it minus or plus x? Minus negative, so plus x. Alright? Now there's a lot of places to make a mistake. You follow? Okie dokie. Last but not least, this is, so this is like, to me, like a Google question, okay? Do you know anything about the company itself, Google? So they are like geniuses, but not just like, I could do the hardest algorithm ever. It's somebody that's like really way out there, creative, thinks in different ways, and their interview process is all this crazy, creative kind of concept to see if you're really that kind of person. It's not, integrate this thing you've been told and you remember 12 years later. It's, can you think just in a totally crazy, different way? That's the kind of people they want working there. This, to me, feels like that kind of question for a calculus student. It requires you to think quite a bit outside the box. So, I will give you some time to think about it, but just as far as the process, let me get you started. This is the kind of thinking you might do. Let's see. How could I go about this? Well, could I go 1 over cosine? Yeah, I don't know what to do from there. Okay. I could say, okay, could you multiply by something? What could you might multiply over itself? It has to stay balanced. Any ideas? Okay, so I might say, I'm getting nowhere here. What if I multiply by cosine over cosine? Does that get you anywhere? Okay. Okay, if that doesn't get you anywhere, then back to the drawing board you go. What else might you do? I could take secant and multiply by something else. That's the, try this, reject it, see if it clicks, or reject it if you run into a wall and keep drilling. Please talk it over with your math amigos. What else could we try? How we doing? Shouldn't this be BBA? And therefore it should be X secant I mean, you have an X secant tangent in there. That was a great idea. So, an approach I hadn't seen before is integration by parts. That was a cool idea, but it doesn't go anywhere. It's a good idea. factor out a negative squared?
No, no. Like if it's like, say, for instance, it's like a 1 minus sine squared. Could I factor out? Could I make u equal the negative sign and I get rid of the negative in the long run?
So you're telling me put, like make a 1 minus sign here?
No, from the cosine over cosine squared.
Oh, I see. Oh, okay, now I'm with you. All right, so let me catch up to you. What
I was
is
trying to get it
cosine?
like RT.
Cosine over cosine square. Oh, so that's actually, so you're back, you're looking at this, I got you. So I'm with you. Now, did you get to this point? D, maybe something like this?
Yes.
Yes, now that would be so good. It's not arctangent, nor is it arcsine. In fact, it's not any inverse trig. That, however, can be integrated by a method that I don't know if you guys know yet. So this is actually what you tripped on is one of the ways to develop this, one of the two. There are two at least that I know. You have to integrate that by partial fraction decomposition and integration of the partial fractions. Do you remember partial fraction decomposition? So if you were to decompose this into two separate linear integrals, you could get there that way. Do you remember your partial fraction decomposition? We are doing that this year. That is a technique of Calc 2. So that's a great idea. Unfortunately, you don't have that skill yet, so maybe try, gosh, it's too bad, because that's a great idea. Anybody else have any ideas? Getting anywhere? I tried this to show you some of the stuff that I thought. That to me felt like, oh, that's something because that looks like a good du, but that's the wrong u for that du, yeah?
Yep.
Then I tried secant times tangent tangent. And that also said, hey, that's looking good. That's a good derivative, but no, that's not the derivative for tangent, so that's also the wrong u slash du combination. Now, if you consider that secants and tangents both have in turn some good ideas, then the way to get going here, I'll give you a hint, is multiply not by a single term, but by, think of what sum over itself you could multiply by. That's the creative step. What could you multiply by over itself? Hey, that's the one. Perfect. That's good for you. That's great. So you already thought of this sum before. You must have done it before. Oh, okay. That's still great. That's fantastic. What's a good sum to multiply by? Obviously, well, I guess I can see sines and cosines, but something great to multiply by is secants and tangents, yeah? So let's try secant plus tangent over itself, right? Now that, I think you'll agree, is mathematically sound because that's just a 1. The numerator becomes secant squared plus secant tangent. Now that's feeling pretty good because those are both derivatives of known quantities, right? And the denominator is secant plus tangent. So now the only question is, does that work u sub style? Well, what would we let u equal? Secant plus tangent. And so what is du? The order is going to change, but that won't matter, right? It'll become secant tangent plus secant squared. And so that is the 1. It's 1 over u du. So natural log of u plus c is the natural log of secant of x plus tangent of x plus c. Now that is how it comes about, and that is exactly what you get if you did partial fraction decomposition, it would get you there. But I would probably commit that to memory because I'm not expecting you to derive that every time. I just want you to know where it comes from, right? Use the same kind of thought process for the last one we don't know, which is cotangent, cosecant rather, excuse me. Instead of secant plus tangent, you'll probably use and because you have negatives in the derivatives here, you might consider maybe it won't just be straight up addition. So I tried cosecant plus cotangent and I do not get the true or regular form. I don't know if you're getting the same kind of thing, but you get this weird stray negative, yeah? Okay, so are you getting something like the opposite of log of cosecant plus cotangent? That's true, but that is not the common form you'd see in a text. So I appreciate your good calculus, but the accepted form that you'll see, and therefore probably on a multiple choice, would be something like to multiply by cosecant minus cotangent. If you do that, you'll get the more common form you'd see in the back of any text. Issues. Negative cotangent of x plus cosecant x dx. So it looks something like 1 over u du. The negative is not really an issue once you substitute. It's the natural log of the cosecant minus the cotangent. That's the more common form. Okay? All right, so those are your 4 antiderivatives. You should eventually get down cold memorized so you don't have to redevelop it every time. Wait. All right, do you still have 98? Okay, 98 questions. Let's get 98 knocked out at least, and maybe 99 if we can. Where are we at on 98, Joe? 98. Your test Thursday is through last week's stuff, so 98 or 99. Oh, differentials, 99. Test is through 99. That feeling good? Through 99. Okay, questions on 98? Four. A what? 20, okay. 20, 4 and 20. Boom. Okie dokie. 98, 4 is for a change or just straight up book. Okay, 4 from 98. There we go. Okay, acceleration is pi sine pi t. The velocity at time 0 is 0. That's given. That's nice. And they want the average velocity on the interval 0 to 1. There are two ways to find average velocity. X change in position over change in time, or average value of the velocity. These are equivalent if you think about it. If you did the integral, wouldn't it be the antiderivative is x, so x would be minus x at a. These, they're the same. Okay. Unfortunately, we have neither x nor v, we have a. So the question is, which one are we closer to having, x or v? V. We're closer to v when we're at acceleration. So I'm thinking this would be the way to go. We first need to acquire v, though. So if v is the antiderivative of the acceleration, then wouldn't you agree that v is cosine, negative cosine of pi t plus c? Does that check out if I took a derivative? Positive sine pi t times pi? Yes? Do you agree? All right. If I use the initial condition, 0 equals negative cosine of 0 plus c, it seems like c is 1. So, if the velocity is negative cosine of pi t plus 1, then we can find the average velocity by going 1 over 1 minus 0, from 0 to 1, of negative cosine pi t dt. Right? All right. Oh, I sure did. Thank you. Plus 1. Okay, good call. So the antiderivative of negative cosine pi t. I guess you could use sub that, but it sure seems like a shame to have to use sub that with limits of integration. So could we just mentally say what constant would we have to have in order to deal with that pi? Is it pi or 1 over pi? 1 over pi, negative 1 over pi sine of pi t plus t. I could check that real quick with the derivative. And I feel like that would be correct from 0 to 1. Then it's negative 1 over pi sine of 1 plus 1 minus negative 1 over pi sine of 0 plus 0. That's sine of 1 pi, thank you. So that zeroes out. That zeroes out. That zeroes out. So all that's left is 1. A lot of technique to that problem. Okay? Good problem. All right. Are we good? 20. Well, let's finish that idea. we are trying to show if x minus, if x minus 2 is less than a tenth, then it must follow that f minus 3 is less than 2/10. Sweet. Okay, you start with x minus 2 is less than a tenth, and you play with it, do a little math thing each side, keeping the equation balanced until you get to f of x minus 3 is less than 2/10. So I want to take that and take it to here, which the step before that would be something like this. So I really want to take that to there, and I'm home free, yes? Because if I can get it to 2x minus 1 minus 3, I can replace 2x minus 1 with f of x, and boom, we're good. All right, so looking at that, looking at both sides, I want this to be 2x, not x, and I want that to be 2/10, not 1/10, so it seems logical to multiply both sides by 2. Weak. Some of this is going to be rules of absolute value. One rule is that there's zero reason I can't replace 2 with the absolute value of 2, because they both equal the same thing. Yeah? Another rule of absolute value is it doesn't matter if you have two things multiplied, if you make both things positive, then multiply, or if you multiply and then make the product positive. The answer will come out exactly the same. Therefore, the left-hand side, rather than call these two separate absolute values, I could say it's the same as the single absolute value. Now, if I distribute, that's 2x minus 4 in the absolute value. Yeah? We're so close. How do I get from there to where I want? Well, is there any reason I can't break up subtract 4 to subtract 1, subtract 3? Ooh, that is totally allowed. I can call negative 4 minus 1 minus 3, and then that minus 1 can be used to make my f of x. And boom, you're good. Now that's the guts of a delta epsilon proof. We'll do that, I think, tomorrow. Or is it Tuesday? Delta epsilon proof. Yes, I think I put it in 101. Good. 103 is first. Okay. All right. We're good. How about? That's all we need to do set 99. Any questions on set 99? What? Couple more on 98. Come on, Eric. All right. Yeah.
I saw it happen. He's like, wait, you're like, everybody's good. He's like, and you're like, all right.
Is that a problem?
Eric's not
Can we
good.
just
We can't
leave Eric behind? No man left
We're a
behind.
team.
I'm not trying to be a child.
You're the child left behind.
Can you do 25?
Hey,
Yes. 25 actually goes with 22 on 99, so that's a good one. 25, is that the buoy problem? Okay, so there's one boat going this way at 4 miles per hour, or n miles per hour, and there's another boat.
Should I pass this?
What's this? Are we really putting our time sheet for a party? Really?
Oh wait, disbursement, you know what? I think I figured it out. I was reading about it.
Oh, that'll do it. Okay. All right. 98 then, we're good?
yes.
Okay, 98 and 99 are good?
And 99?
No.
That's fine with that.
Whatever. No, I
That's
didn't.
99.
That's number 3.
On 99?
Yeah.
All right, 98 's new, but not 99.
I got that.
I forgot to put the key up to 99. I'll put that on my website tonight. And we can check it out tomorrow. All right, we're done. Good day. Good day.